Okay, so now it's 2 o'clock. Okay, Daniel, Mike. Okay, so I think we can proceed to start our chapter 1 first. Okay, so welcome back to our Taylor's University. Kumar, how are you?
Hi, I'm good.
How was your industrial training?
Too easy already.
Or too easy, Okay.
Yeah.
Hope you can pass this module also, Very simple,
I will try my best.
Okay, thank you.
Thank
Okay, thank you. Okay, so now, thank you. Okay, so welcome back to Taylor's University. Okay, let me introduce a bit, for this module before we officially start our first chapter today. Okay, so this module, is process plant design and economic. Okay, this module is very, 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 very important, especially to a chemical engineer. Okay, because as a chemical engineer, we need to know how to apply our knowledge, in order to come up with a design, to design a chemical plant and make sure it can be safely constructed and safely operated in order to produce the chemical or product that actually we want to produce. Okay, so meaning that, so in this module we call process plant design. Okay, we will try to learn how actually we can try to apply the knowledge that we learn, from other module in order to try to integrate them together, to combine them together in order to come up with a design, to design a chemical plant in order to produce the chemical that we want to produce. This is what we call process plant design. Okay. Okay, this is what we call process plant design. Okay, not only we have to know how to design, not only to design a chemical plant, but we also need to make sure the chemical plant that we design is actually able to gain profit, to earn money based on the chemical or product that we produce by using our design. So that's why in this module, we will also cover the economic part in order to evaluate the cost. What is the cost, in order to construct the chemical plant that we design? And also we will try to learn how to calculate, for example, the break-even point or the gross profit, based on the design, the chemical plant that we design. Okay, this is actually the main objective of this module. Okay, so now we continue.
There is fire in the building.
Fire emergency.
What fire emergency?
Why, sir? Good knowing you.
What fire emergency?
I don't know.
In another BG classroom, there is an announcement to evacuate.
Okay, then never mind, we proceed. Okay.
I think give us 5 minutes to relocate.
What happened?
There was a fire announcement. Okay.
Really?
Yeah. Just yeah. The mic. Just a second, sir.
Fire drill, is it?
Not so sure if it's take a real, but everyone's leaving.
Okay, never mind. Okay, by the way, I'm still recording the lecture. You all run away first, okay? And continue later. Okay? Okay, so never mind.
Thank you, sir.
Okay. Okay, so never mind, we proceed. Okay. So, okay, basically for this module, yes, we have lecture and also tutorial. Okay, we don't have any practical for this module. For lecture, it will be conducted every Tuesday, 2 to 4 p.m. by using the link that I provided to you. Okay, the similar link. Okay, it will be conducted by using the online face-to-face method. But for tutorial, we will do it physically in the campus from 4 to 6 p.m. Okay, Wednesday, means tomorrow. Okay, but be careful for the tutorial, even though it will be conducted physically in our campus, but be careful. For week 4, week 5, and week 6, we will use the computer lab to conduct our tutorial. Okay, C704. For week 1, 2, 3, 7, 9, 10, 11, 12, 13, 14, we will use the normal classroom, which is BG12, to conduct our tutorial. Okay, so be careful with this one. Okay, so basically, as I told you just now, for this module, we will try to learn actually how we are going to try to combine and integrate all the knowledge that actually we learn from other chemical engineering core module in order to come up with a chemical plant design. Okay, so that's why in this module, not only I will try to guide you how to combine and integrate this knowledge, but also I will try to guide you how to actually we can try to select a suitable equipment, how to come up with a mechanical design for the equipment that you select, and also how we can make sure the process is actually can be operated safely. Okay, and also I will try to share with you some of the factors and also the consideration that we need to consider when we design the chemical plant, especially the safety and also the sustainable aspect. Okay, and also I will try to guide you how to estimate the cost, okay, for the chemical plant that you design, okay, and also how to calculate the gross profit, okay, ROR, okay, cash flow analysis, and so on. Okay, all of them will be covered in this module also. And basically, these are the main content that we are going to cover in this module. Okay, here is the assessment plan. For this assessment, we have one test, which will be conducted in week 7. Okay, it contributes 10%. And also, we have 2 different assignments for this module. Assignment 1 is a group assignment, contribute 40%. And the due date you need to submit the assignment 1 is in week 10. For assignment 2 is an individual assignment, and the due date is in week 13. Okay, contribute 40% for assignment 1 and 20% for assignment 2. For final exam, it only contribute 30%, and it will be conducted during the final exam week. Okay, so far, any question before I proceed? Okay, for those who enter late, okay, never mind, okay, because I'm recording the lecture, so later I will share the link with you. So in case you are late, then you can actually rewatch the lecture later. Okay, so this is the assessment plan. Okay, I assume no question. Okay, then maybe I can proceed. Okay, here are the references or the reference book that we are going to use and refer, okay, in this module. Okay, so in case you need any reference book or you need some extra references, okay, you can try to get the references or maybe download the ebook, okay, based on the learning material that I share with you here. Of course, you can also try to refer to some of the textbook or maybe the ebook that you think they are actually suitable for this module also, okay? Okay, so now, okay, we proceed and start with our lecture 1. Okay, for your information, for our lecture 1 today, you will, I would say, is 100% focused on the theory. And also for our chapter 2 and chapter 3, they are also focused more on the theory. But chapter 2, it involves some of the simple calculation, okay? But for chapter 1 and chapter 3, I would say they are mainly focused on the theory. So that's why I would say our today lecture, okay, will be a bit boring, but I will try my best, okay, to make it as interesting as I can, okay, so that you won't fall asleep, okay? Okay, and one more thing, okay, even though our today lecture is actually more on theory, okay, fully focused on theory, but make sure you try your best to understand the content and also a theory that I'm going to share and explain for you. Why? Because this idea is actually very, very, very important. Okay, why? Because later in your final year, in your semester 7 and semester 8, you have another module we call Chemical Engineering Design Project 1 and 2. Later in the Chemical Engineering Design Project 1 and 2, you are going to apply all the knowledge that you learn in this program, okay, from year 1 until year 3. You need to try to combine and integrate all the knowledge together. And of course, you need to consider the theory that I'm going to share with you in order to really to come up your own design, in order to produce a chemical plant, in order to produce a chemical or product that you are going to produce. You need to start from zero until you complete all the design, and also you need to try to evaluate the profitability, okay, of the chemical plant that you are going to design. So that's why this module is actually very, very important, because it can be considered as a stepping stone, okay, in order to prepare, okay, yourself in order to know how to actually come up with your own chemical plant design. Okay. Okay. So basically in our lecture 1, the theory that we are going to cover is, okay, I will try to explain to you what is plant design, and also what are the consideration and also the factors that actually we need to consider when we design the chemical plant. Okay. This one is not that simple, very complicated. It can be very complex. Okay, and also I will try to introduce and share with you what is process design development. Okay, what does optimum design means? Okay, and also what are the practical considerations that we need to consider when we design the chemical plant, and also some of the very common approach to design, and also some of the engineering ethics that we need to follow, okay, when we design our chemical plant. And lastly, I will try to share with you and explain a bit actually what is plant life cycle. And basically, these are the theory that I'm going to cover in our today lecture. Okay, so remember, okay, please make sure if let's say you have any doubt or you need any extra clarification, okay, either you can switch on your mic or maybe you can type your question in the chat box. Later, I will try to assist and answer your question. Okay. Okay. Kumar is not here. Okay. Kumar lost in fire. Okay.
I'm here.
Oh, okay. You are here, Kumar. Okay. Who set the fire just now?
Confirm not me, right? I said the fire confirm. I'm the one who's the one to be escaped, right?
Okay, thank you. Okay, I just asked you who set the fire. Okay. Wow, so long-winded. Okay. Edmund is here, Bernard is here, Jinhan is here, Uma is here. Okay, Shini. Okay, Shini missing in action, lost in action already. Okay, then never mind, we continue. Okay, so now, okay, as I told you just now, as a chemical engineer, okay, you need to know how to actually you are going to apply the knowledge that you learn in other module. For example, material and energy balance, mass transfer, process control, what else? Separation process. You need to know how how you can actually apply this knowledge that you learn in this module in order to combine and integrate them together in order to come up with a chemical plant design. Okay, so as I told you just now, okay, there are some of the modules that are actually very, very important. And they are actually very useful when you come to the chemical plant design. For example, mass and energy balance, compulsory you have to know. Because when you come up with a design, of course you have to know, okay, what is the amount, okay, of the material that you are going to handle in the equipment and also in every single process stream that you are going to handle before you are allowed and you can proceed to design the size of the equipment and also the pipeline. And also is also very important, you know, you have the knowledge of thermodynamics, because you have to know actually what is the thermodynamic equation that you are going to apply in order to calculate or estimate the volume of the gas that you are going to handle. For example, you are going to use the ideal gas or real gas equation. Okay, you need to decide yourself in order to come up with an accurate answer or estimation. Okay, and also later in your chemical plant design, you also have to know how to apply the suitable reaction kinetic knowledge that you learn in CRE, chemical reaction engineering, in order to try to control, okay, or determine the suitable reactor that you are going to use in order to carry out the chemical reaction that you want in your chemical plant. And also heat and mass transfer, also very important, because you need to know, okay, how the heat is going to transfer, how the mass is going to transfer, so that you can consider the important concept in your design also. Okay, and of course, not limited to this module, and there are also a lot of different module. You might need to apply the knowledge in your chemical plant design later. Okay, and it depends on the chemical plant and also the chemical process that you are going to, okay, design and handle. So that's why remember, okay, now I think most of you are in year 3 as a chemical engineer. Okay, you are going to officially become an engineer, a chemical engineer. So now you have to make sure, okay, you know how to apply this knowledge and integrate them together in order to come up with a chemical plant design. Okay, so now, not only to apply and integrate the knowledge that I shared with you just now, as an engineer, especially a chemical engineer, if let's say now you want to come up with a design, you want to design a chemical plant. Also, you are expected, okay, to know how to initiate a chemical plant design. What you are going to start, what is the information you are going to collect and compound, okay, who you are going to discuss and deal with, okay, before you can officially initiate your chemical plant design. Okay, once the design, the idea is initiated, how are you going to develop a new chemical plant? Okay, how are you going to select the most suitable synthesis process? what is the most suitable equipment you are going to select and put in your chemical plant design. All of this you have to know as a chemical engineer. Okay, so okay, maybe some of the company that already have their own chemical plant, but suddenly the investor or their boss or lady boss, suddenly they are very rich, okay, they have a lot of money. Now they want to try to further expand their chemical plant. Okay, as a chemical engineer, okay, you are also expected, okay, to know how to expand the chemical plant that we have in our company, okay, in order to maybe to assist your boss, okay, or investor, okay, to get more profit. And also, okay, in some of the industry, yes, okay, they already have their own chemical plant, but maybe they think their chemical plant can be further improved, okay, either to make them to become more eco-friendly, or maybe it can be further improved to further increase the efficiency, to improve the amount of the product that can actually produce by using the existing chemical plant. Okay, as a chemical engineer, you are also expected to know how to apply the knowledge that you have and learn in this program in order to assist them to try to revise or improve the existing chemical plant. All of them are considered as the task that normally we will assign to a chemical engineer in an industry. Okay, so as I told you just now, okay, as a chemical engineer, of course, we have to know, okay, how to apply our knowledge in order to design the chemical plant. But when we design the chemical plant, we are not going to only apply the knowledge that we learned in the chemical engineering core module, but also there are a lot of different factors or external factors we need to consider in our design. Okay, for example, environment, safety, health, okay, concern. Okay, these are some of the factors that normally we will also try to include it in our consideration before we finalize our chemical plant design. Why? Okay, because we need to make sure the design, the chemical plant that we are going to design, first, can be safely operated. Second, it won't give a huge impact to the social, okay? And also, we need to make sure it is also eco-friendly. And the most important, it must be practical realization. Practical realization, that means the design, the chemical plant that you are going to design, it can be really, okay, constructed in the industry and safely operated in order to produce the product that you want. This is what we call practical realization. Or in other words, that we need to make we need to make sure the design that we are going to come out is actually practical enough and can be really practiced in the real world situation. Okay. But actually, if let's say you want to come out with a chemical plant design, it can be very, very complicated or complex. Why? As I told you just now, because you need to integrate all the knowledge that you learn in this module in order to come up with a design. And also, not only apply the knowledge, you also need to consider a lot of different external factors and also consideration to make sure the plant that you are going to design can also address most of the concern nowadays. Okay, and the most important, okay, it can be really practiced in the society. Okay, so that's why, okay, for chemical plant design, okay, the process to come up with a complete design, it can be very, very complicated or complex. Okay, and the most important, we also need to make sure the chemical plant that we are going to design, that we produce, can also make profit. Okay, okay, even though the chemical plant design is not simple, okay, it's very, very complicated and complex, but remember, okay, the process design or the chemical plant design is actually an open-ended task. Okay, meaning that, okay, actually we have the freedom, okay, we can decide what are the synthesis process that we are going to apply and use in the chemical plant design. Okay, and also as a chemical engineer, we also have the right to decide the sequence or arrangement of the equipment in the plant design. Why? Okay, because first we need to make sure the design that we come out, okay, is actually we can make profit. Okay, and also it can also address most of the other external factor and concern that actually we want to address. Okay, so that's why, okay, fortunately, okay, chemical plant design is an open-ended task. So that's why actually we have a very high degree of freedom in order to allow us to fulfill all the factors consideration, okay, and also the criteria that we want to fulfill. Okay. Okay, normally, okay, in our chemical plant design, okay, we will try our best to make sure all the elements that we are going to consider and include in our chemical plant design, they are actually an optimum design. Okay, so an optimum design means that, okay, all the selection and decision that we are going to make, okay, in each of the stage or step that involved in the chemical plant design is the best selection or the best option. This is what we call optimum design. We call optimum design. Okay, if possible, we want to make everything, okay, optimum. But as I told you just now, okay, we have a lot of criteria, for example, profitable reality, and also a lot of external, a lot of consideration we need to consider in our design. And some of the factor and consideration, no choice. We have to fulfill, we have to address. So in order to address these external factor or consideration, and the most important is the profitable reality, sometimes we cannot, okay, select the most optimum design, okay, in the step that involved in our chemical plant design. Meaning that, because sometimes we need to address some of our concern or our or the criteria that given by our customer or our boss or investor. Sometimes because we want to fulfill this concern or criteria, okay, some of the element of some of the stages, even though we have the best option, but we cannot go for the according to the best option. Why? Because we need to fulfill the criteria or the factor that given by our stakeholder. Okay, so sometimes even though the element they given, the option they given is the optimum, but sometimes if let's say we proceed with the optimum element, okay, or optimum selection, okay, even though it's optimum, but we cannot meet the criteria or consideration or even requirement they given by our stakeholder. So in that case, no choice, we need to give up, okay, ignore the optimum element, then maybe we proceed with another selection to make sure it can actually fulfill the criteria or the selection or the factor they given. So that's why, okay, most of the chemical plant design, okay, that we are currently using in the industry, okay, most of them, okay, I would say almost 99% of them, they are not a full optimum design. Why? Due to the criteria and also some of the external factor that we need to consider and also fulfill. So that's why we need to, okay, go to the second option. Okay. Okay, so now we proceed. Okay, so as I told you just now, as a chemical engineer, of course, we have to know how to apply the knowledge that we learn in order to come up with a chemical plant design. Okay, okay. Even though we are a chemical engineer, but we also need to take up the role of design engineer and also the role of cost engineer. What is design engineer? As I told you just now, when we design a chemical plant, okay, we design a chemical plant, okay, we need to try to integrate all of our knowledge in order to come up with a chemical plant, okay? Once we finalize the process that we are going to apply, the material that we are going to handle in every single process stream and also in the operation, unit operation, okay? What we need to know is we also need to determine or calculate the size of the pipe and also the size of the unit operation. For example, the size of reactor, the size of distribution column that we are going to construct in our chemical plant design. If let's say you deal with the design, especially the mechanical design part of the unit operation and also the pipeline, then, not the pipeline. Okay, if let's say you deal with the mechanical design of the unit operation, okay, for example, reactor, distribution column, and so on, then you are also considered as a design engineer. Why? Because the role or the main function of a design engineer, okay, is to design the mechanical part or the drawing of the equipment that you are going to use in your chemical design, in your chemical plant. And also, you also have to know, okay, compulsory, you have to know how actually you are going to calculate the cost that require in order to construct and complete the chemical plant here. Because since you already come up with a chemical plant design, okay, you are going to construct this chemical plant. Then of course, okay, you need to come up with a very, very detailed costing to calculate what is actually the total amount, okay, that your stakeholder or investor, they are going to invest in order to construct the chemical plant here. And also when, okay, how many years they need to take in order to break even, okay, okay, and also how is the profit, okay. So remember the industry, okay, the main function of the industry, not only to produce a product, they are actually doing a business, they want to make profit. So that's why it's very important. You need to make sure the design, the chemical plant that you are going to design can assist your boss or the stakeholder or your customer to make profit. Okay, so if let's say you deal with the costing, then you can also consider yourself as a cost engineer. Okay, so remember, okay, even though we are a chemical engineer, but no choice, okay, we have to know, okay, not only how to come up with a chemical plant design, but you also have to know how to design the equipment that you are going to use and also calculate the cost for the chemical plant that you design. Okay, and also, okay, accept the design of the chemical plant, okay, the mechanical design and also costing. As a chemical engineer, later you also need to prepare a plant layout based on the chemical plant that you are going to design. Plant layout, that means how are you going to place your equipment? how these equipment they are going to link together. Okay, which part of the region you are going to put your decision column. Okay, where you are going to construct your control room, where is your toilet, where is your storeroom, where you are going to install your storage tank. So you need to try to decide, okay, and what is the distance between, let's say, between the distribution column and also the storage tank. What is the distance here? Okay, all this you need to design. Okay, this is what we call plan layout. So that's why as a chemical engineer, you are also expected to be able to come up with a very detailed plan layout. Okay. Okay, so far, any question you want to ask me before we proceed? Okay, Shini, how are you? Long time no see. Hey, Shini, are you there? Okay, Shini is not here. Okay, Shini missing in action already. Kuma,
Yes,
are you there? Are you there?
of course I'm here.
Where are you now? In campus?
Yeah,
Why you are in campus today?
because I got class at 4 to 8 later.
4 to
Face-to-face.
8
Yeah.
face to face. What module is that?
Good question. After this only I need to check.
Okay, good luck. Wow, that means you have a lot of back-to-back classes. What, 2 to
Today
4,
8
4
hours
to 6,
class. 12 to 8.
12 to 8 non-stop.
Yeah, no break.
Then how you are going to take your lunch?
That's why lah. Tailors always treat me like slave like that.
Hey, never mind. This is also a secret. How you maintain your body shape? Okay. So slim.
I already like skinny already. Want to be more skinny now.
Okay, thank you. Okay, you can build yourself. Okay, thank you. Okay. So, okay, Shini, any question you want to ask me before we proceed? Okay, make sure you understand all the theory and all the story that I share with you, because later you are going to apply what I'm going to explain here, the theory here, to start your project in your final year, and also the assignment in this module. Okay, so now we proceed. Okay, time is money. Okay, so we proceed. Okay, we continue. Okay, so now I want to try to explain to you, okay, these 3 different definitions. Okay, first, you need to understand. Just now, okay, I try to explain to you actually what are the tasks that normally will be assigned to a chemical engineer in the chemical industry. Okay, so beside that, okay, we also have to know, okay, what is process engineering? Okay, what is process engineering? Okay, process, I think should be no problem. You know the meaning of process. Process, that means the process lah, okay, that you are going to carry out, okay, in order to produce something. For example, okay, chemical reaction, okay, yes, it can be considered as a process. If let's say you want to mix component A and component B together, okay, you are going to apply the mixing process. Then the mixing is also considered as a process. If let's say we combine the process and engineering together, that means it can be considered as a discipline that we expect the process engineer to try to apply the scientific process that they know in order to achieve the task or maybe to produce the product that they want to produce in the system. Okay, so meaning that as a process engineer or process engineering, later the process engineer, they are expected to try to select the most suitable process in order to assist, okay, their boss or customer in order to produce the product that they are going to produce. And the process that they are going to select, not only the most suitable one, but they also need to consider the economic part. Meaning that they also need to make sure the process they are going to apply in the system to produce a product not only is the most suitable process, but if possible, they also want to reduce the cost in order to increase the profit margin that actually the stakeholder or customer that can get. Okay. This is what we call process engineering. But remember, for process engineering, they only assist you to select the process, but they are not going to assist you and they are not going to come out or design a chemical process plant. This is the main difference between the process engineer and chemical engineer. Okay, and some of the process engineer, they even don't have the knowledge how to actually to initiate the chemical plant design. Okay, this actually can be considered as one of the aspects that make the process engineer different from the chemical engineer. Okay, so beside that, just now we focus process engineering or process engineer. How about the process design? The process design means that we are going to design the equipment and also the facilities that we are going to use, okay, in the chemical plant in order to carry out the process that we already selected in order to meet our objective or target or produce a product that we want to produce. This is what we call process design. Okay, they design the equipment and also the facility. Okay, but not a chemical plant. Not a chemical plant. They only focus on the design of the equipment and also the other facilities. For example, wastewater plant, heat exchanger. Okay, these are known as equipment and facility. They are only focused on the design of this element only. But they are not going to do a complete chemical plant design. This is what we call process design. Okay, now look at here. Plant design. What is plant design? Plant design, that means we will expect the engineer, okay, especially the plant designer, okay, in order to come up with a very, very complete chemical plant design. For example, you have to know how to prepare the complete plant layout. You have to know how to select a suitable location in order to construct the plant that you are going to design. Okay? And also you have to know how to design the P&ID. How are you going to install the suitable valve or alarm to control the chemical plant or chemical system? And also you are, as a plant designer, you are also expected in order to know, okay, to decide what are the variables that you are going to control and look after or monitor to ensure the chemical plant can be safely operated. This is what we call plant design. And basically, these are the differences among the process engineer, process design, plant design. Remember, process engineering, they only select the most suitable process, but they are not going to design. Process design engineer, they only design the equipment and facilities that you are going to use in the chemical plant. But they are not going, they don't know how to come up with a very complete chemical plant design. Okay? So for plant design, means that you need to include, okay, how to select the suitable location for the chemical plant, how to come up with a very good layout for your chemical plant, and also PNID and so on. This is what we call plant design. So meaning that this module is known as process plant design. So meaning that later for this module, process, you have to know how to select the most suitable process for your design. And also you are expected to know how to design the most suitable, the size of the suitable equipment and facilities that you are going to use in your chemical plant design. And also you are also expected, okay, to come up with a complete piping and instrumentation diagram, PNID diagram. You are also expected to know how to select the most suitable location for your chemical plant, and also come up with a very complete layout for your chemical plant. Meaning that these are the 3 elements that we are going to deal and cover throughout this module. So this is also a reason why this module is known as process plant design. You see, so how important, okay, is a chemical engineer. There is also a reason why I keep telling you the pay, okay, for chemical engineering normally is higher than the other discipline. Why? Because we are expected, okay, to apply our knowledge to come up with a very, very pragmatic and also the complex design for our chemical industry. And some of our task is, I would say, is very, very complicated, okay, and not simple at all. Why? Because except the element that I try to explain with you here, there are also a lot of other regulation, criteria that given by your customer, and also the concern that actually you need to consider and address in your design here before you come up with the final design. Okay. Okay, so now we proceed. Okay. So similar to what I tell you, what I told you just now, okay, there are a lot of consideration we need to consider in our chemical plant design later, okay, especially the environmental. You need to make sure the design is eco-friendly, and also you need to make sure the plant that you are going to design and construct can be safely operated, okay, to produce a product you want. And all of these aspects and external factor and also the regulation that given by our government should be always addressed and considered in every step that involved in our chemical plant design. Okay, and when you try to include all these external factor, regulation, and also consideration, all of them will actually influence and change the economic performance of the chemical plant design that we are going to design. Okay, so that's why, okay, of course, money is very important because industry, okay, they want to make profit, okay, they are not a charity, okay. The reason why they sell a company, why they are doing a business, because they want to become millionaire, okay, they want to make profit, okay. So that's why, okay, you need to make sure the chemical plant that you are going to design can actually fulfill the expectation that given by your boss or customer. But at the same time, okay, you also need to consider all these consideration and external factor. Okay, you cannot say because you want to become millionaire, okay, you want to increase your profit margin, then you sacrifice the important consideration here. Cannot. Okay, you need to always, okay, bear in mind, consider them and include them, okay, if possible, okay, in every single step or element that involved in the chemical plant design. Okay, but of course you need to look after the economic performance of your design also. Okay, if not, even though your chemical plant that you are going to design is very eco-friendly, high novelty, no carbon dioxide will be released, but the economic performance is relatively low, then normally your customer or even the investor, especially your boss, okay, normally they are actually not interested, okay, in investing in this kind of chemical plant design. Okay, so that's why you have to know how to get a balance point between the economic and also all the important aspect that we need to consider as a chemical engineer. Okay, so now, okay, beside the factor that I explained just now that can influence the profit or the economic performance, some of the other consideration that we apply in our chemical plant design, they can also determine and influence the economic performance of our chemical plant. For example, the plant location, where you are going to construct your chemical plant. Either you want to construct your chemical plant in, let's say, in Subang Jaya, or maybe in Pasir Gudang, Johor. Different area, different region, the land price is totally different. And it will also influence your cost. Okay, so this is how that it actually can determine, okay, influence your economic performance. Beside that, how are you going to join the equipment and the unit operation together? How are you going to arrange them? Okay, the plant layout will also determine the cost, the cost of your chemical plant design, and also influence your economic performance. Okay, because how are you going to arrange? How are you going to connect them? It will determine the amount or the money that you are going to spend for the pipeline construction. Or don't forget, pipeline construction, you are going to connect them together. You also need to, okay, spend a lot of money. Okay. Beside that, okay, how are you going to make sure the plant can be safely operated? Okay, for sure you need to install the control valve and also control the variable and control the process. But your design, okay, I mean the design in the P&ID, how are you to control the chemical plant? Okay, they are also to determine and influence the cost that you are going to spend to install the control system as well. Okay, the control valve, okay, and also the system, and also how are you going to monitor them? Okay, the installation of the the control system, very expensive. So that's why when we try to come up with a P&ID, not only we just want to control the system, control the variable, but if possible, we need to figure out, okay, is there any alternative we can actually properly control the variable, monitor and control the chemical plant by using to keep the cost that we are going to spend to install the control system as low as possible. Okay. Beside that, utility requirement means that the hot fluid that you are going to use to increase the temperature of the process stream, or the cold fluid that you are going to use to cool down the temperature of the process stream. Okay, all of them will also determine the money that you are going to spend. Okay, and also, okay, the building, how are you going to construct? Okay, how are you going to store the, let's say, the raw material and also the product that you produce? The storage will also determine the money that you are going to spend. If let's say now you have a product and the product must be kept, let's say, below -10 degrees Celsius. Wow, you see, now the temperature is lower than our room temperature, and some more is negative. Then later it will significantly increase the price that we are going to spend, okay, in order to come up with this kind of storage system. And also the structural design of the chemical plant, you are also determine the price, also the cost for your chemical plant design. And also any hazardous material you are going to produce by using the chemical plant that you design. If yes, how are you going to handle and dispose this hazardous material? So all of them will also, okay, increase the cost of money that you are going to spend. So that's why you see, actually there are a lot of different factors, or even our design, that can actually determine the cost that we are going to spend, okay, in our chemical plant that we are going to design. Okay, so now look at here. Here is very, very important. Okay, this one is very, very important. Why? Because just now I just try to explain and brief you what are the tasks that actually we are going to do in the chemical industry as a chemical engineer. And also what are the considerations we need to consider in our chemical plant, and how this consideration, our selection, and the decision that we are going to make, how it can actually influence our design, especially the economic performance. Okay, so I hope so far what I explained to you just now, hopefully, okay, I hope, okay, you all are clear, okay, and so that you won't have any problem after this. Okay, why? Because the idea, as I told you just now in this chapter, very important. Later you are going to apply them, okay, in your final year project and also the assignment in this module. Okay. Okay, Kumar. So far, any question? Anything you want to ask me?
No question.
No question, so far.
Yeah, so far.
Clear?
After this, also I won't have question.
Okay, thank you.
Okay, bye.
Now we proceed. Okay, look at here. What I'm going to explain, the step here, they are actually very, very important. And especially when you want to initiate a chemical plant design, to come up with a design for the chemical plant that you are going to design. Okay, so now, okay, look at here. Uma, don't play. Open your eye. Okay. Here we call process design development. The process design development that I'm going to share with you and explain here is actually can be considered as a guideline to guide you how to initiate a design to design a chemical plant. And also what are the elements and also the stage that involve in order to assist you to complete a chemical plant design. This is what we call process design development. And similar to I told you just now, process plant design, the chemical plant design is actually an open-ended, meaning that we don't have any correct or wrong answer. Meaning that how are you going to design a chemical plant? We don't have any fixed SOP to follow. So that's why I told you just now already, chemical plant design is considered as open-ended. Okay, and actually there are a lot of different guidelines of framework have been proposed by the engineer. Okay, and among these guideline and framework that proposed by the engineer, we already selected the most common one for you. Okay, and this framework that's selected and included in the lecture notes here are the framework or the guideline that normally we will apply in our chemical plant design. Okay, the first one is the process design development that proposed by Mr. Peter, okay, in 2004. And the second guideline or framework of process design development that proposed by the Shidou in 2010 is also one of the common guideline and framework that we normally refer to in order to design a chemical plant. Okay, so in other words, okay, as I told just now, there are a lot of framework or guideline have been recommended, suggested, or shared by the scientist or the engineer. But among of them, okay, the most common one that we normally apply to assist our chemical plant design is the one that proposed by Shidou and also Peter. So that's why in this lecture, we will mainly focus to the framework or the guideline that proposed or recommended by Peter and Shidou. So far, any question before I explain to you step by step? No one? Okay, remember? Okay, here is the guideline, here is the framework. And actually the framework and guideline here, they are actually provide the important information to assist us in order to complete our chemical plant design. So let's say if we want to refer to the framework or guideline that proposed by Peter, first step, we need to recognize the need. What is recognize the need? Okay, for example, now you want to start with a chemical plant design, right? My first question, what is the product you are going to produce? This is what we call recognize the need. That means you have to know what is the objective. Okay, what is the objective you want to come up with a chemical plant? What is the final product you are going to produce? This is the first step we call recognize the need. Okay? Okay. So some of the company, they have their own sales department or marketing department. And normally they will do some survey or market survey to identify the potential product that they want to produce. So, and based on the potential product they are going to produce, then as a chemical engineer, you need to try to propose a chemical plant, to design a chemical plant in order to assist them to produce the product. Okay, this is what we call recognize the need. And sometimes, okay, if let's say we are a consultant, okay, some of the customer, they can also approach us, okay, since we are a chemical engineer, okay, maybe let's say they want to produce dynamo. Okay, they want to produce a plant to produce dynamo, but they don't have the knowledge. So that's why they try to approach you. Then as a chemical engineer, you also need to assist your customer to fulfill their need to come up with the correct chemical plant. Okay, or maybe you have some idea, you want to produce some of the potential product that you think you can make profit based on the product that produce. Okay, then of course you can also come up with your own design in order to produce the product that you want. Or some of the scientists, they already come up with a new technology to produce a new product. But unfortunately, this new technology or new product is currently only limited in the lab only, is under the research still, and now you want to try to commercialize this kind of technology or product, then of course you need to try to increase the skill, okay, of the technology, okay, to further expand it, okay, to become a pilot plant or chemical plant, okay. Then this is also considered as a recognized need, okay. Then you are going to design a chemical plant also. Okay, so as I told just now, okay, some of the company, they already have their own chemical plant. Sometimes maybe they want to further improve chemical plant. Then you also have to know how to actually develop a new design in order to assist them to try to further improve their existing chemical plant. And this is also considered as the recognized need, meaning the purpose, okay, what actually you want to do, okay. Or maybe some of them, they want to try to modify the existing process they are using in their chemical plant. Then of course, as a chemical engineer, you also have to know how to modify the process so that you can actually fulfill the need. This is also considered as one of the needs under the first step here. Okay. Okay, now once the step number 1 is completed, then now we can actually proceed to step number 2. Create one or more potential solution to meet this need. Okay. Okay, so once you already identify the objective, let's say what is the product you are going to produce, okay, what you are going to do, okay, then you can proceed to a second step. Okay, in the second step here, based on the product that you want to produce or the task that you are going to carry out, you can actually start to identify, okay, what are the information that actually you need, okay, in order to assist you to achieve the target or the objective here. So means that you need to try to Google, download some of the scientific journal article, or even refer to some of the references in order to do some literature survey and try to collect and compile some important information or data, okay, in order to assist you to fulfill the need to achieve your target in step number 1. Okay. Edmund, don't play. Okay, so now we proceed. Okay, Shavich, how are you? Long time no see. Good, okay. So now we okay, just now I told you already, we need to do some literature review, okay, to compile some of the information that you need. Besides that, sometimes we also need to do some pattern search. Pattern search, that means, okay, some of the chemical plant that design is actually already applied IP. But best to my knowledge, some of the IP, they can only last for up to, if I'm not mistaken, it can only last up to 20 years only. One is more than 20 years, the patent actually will be published, okay, on website or some of the references or article, okay. So in that case, you can also try to do some pattern search to see, is there any similar technology have been constructed or designed before that. And based on the pattern search, actually it can also provide you some of the very important information to actually try to assist you to initiate the design for the chemical plant that you are going to design in step number 1 here. Okay, and also, okay, when you do the literature review, you can also try to collect some of the important preliminary data they require in your design later. Okay, means that in form number 2 here, in step number 2 here, you can actually start to try to form a data bank in order to compile and gather all the information. Then later, when you want to design, you can directly to refer to this information. Okay, we proceed step number 3. Okay, step number 3, then we need to proceed to undertake the preliminary process synthesis of this solution. Okay, let's say just now in step number 1, I already decided, okay, Uma, I want to produce dynamo. Okay, in step number 1, I already identified the product I want to produce. So just now in step 2, I already collect all the relevant data from a data bank, okay, or database, okay, and also I do some of the literature review and pattern search. Okay, now in step 3, now is the time we need to try to identify all the possible pathway, okay, system or process that actually we can apply and use to produce the dynamo. This is what we call, okay, preliminary process synthesis. At least we must come up with 2 different possible pathways to produce the product that we want. Then only we can do the comparison to try to compare to see which pathway, which reaction is actually we prefer, okay, in order to use it for the chemical plant design. Okay. And depends on the product that you are going to produce. Sometimes we can come out up to 3 different of even more than 4 different possible different reaction pathway or synthesis pathway. Then in that case, we need to compare among them, okay, in order to select the most suitable process or most suitable technology that we are going to refer and consider as the basis for our chemical plant design. And when we try to compare and select the most suitable technology or process here, there are actually a lot of different aspects we need to consider. First, the most important, money, economic performance. You need to make sure the selected, okay, process can assist you to generate money, profit. Beside that, okay, when you try to select that technology or process, you need to make sure it's actually considered eco-friendly. And some more, if possible, you also need to make sure the selected process is actually safe, can be safely operated. Okay, we reduce the hazard and risk. And also we need to consider the health concern and also a lot of other consideration also. Okay, in order to assist us to try to select the most suitable process or technology as a basis for our chemical plant design. Okay, and normally the most important aspect that assists us to select the most suitable process or technology to form the basis for our chemical design is actually the profit, or sometimes we call it gross profit, or sometimes we call it economic potential, if I'm not mistaken. Or short form we call it EP. Meaning that first, okay, just like I told you, a lot of different aspects we need to focus and consider before we select the most suitable one. But the number one, the top priority is always given to the profitability. If let's say the process can allow us to make profit, then yes, okay, of course we will consider them. Then only we proceed to consider other aspects. But if let's say the process we cannot generate money, okay, we cannot make a profit, then in that case, automatically we will try to exclude them, ignore them, only consider those of the pathway, the selection, they can actually allow us to generate money. Okay, means that we will try to do some screening to try to remove some of the process that cannot earn money, then only we proceed to compare the rest based on the other aspect. This is under the number 4. Okay, Number 5, once the process is selected, then we need to proceed to design the chemical plant. How to design? Okay, we need to try to identify, is there any other important, let's say, the properties of the chemicals or product that you are going to deal in the design unit? Okay, you need to try to start to gather this information. Okay. Okay. Also, is there any other important information, for example, the vapor liquid equilibrium you need in your design later? If yes, then you also need to try to collect them, okay, and keep it, okay, do some what we call the document management, okay, in order to, okay, you can refer for your design later. Okay, and even, okay, some of the technology that you select, they are actually not yet mature. Okay, if let's say the technology that you are going to select is not yet mature and they are only currently available in lab scale, okay, then if let's say you want to refer to this kind of research for your chemical plant design, okay, some of the data, they are actually not available. So in that case, you may need to enter the lab to try to conduct some experiment to collect the relevant or missing information that actually you are looking for. Okay, normally this one is actually applied if let's say the information that you want that actually cannot be found from the website or the information is missing. Okay, this one is normally applied to those of the technology or the process that they are not yet mature and currently only available in the lab scale only. Then in that case, no choice, we need to do some experimental work. Okay, now we proceed to step number 6. Okay, just now we already select the process. Okay, just now we already select the process. Okay, we already compile all the information that require, collect all data that require. And now we have a lot of different information. Okay, then now what we can do is we can start and proceed to our chemical plant design. Okay, first, what is the base case? Okay, just now we already know what is the product we are going to produce. And also we already identify the most suitable process or technology to produce our product. And these all are considered as the base case of our chemical plant design. Meaning that the product that we are going to produce, the technology or process that we are going to select, they are actually considered as the basis that actually it allows us to know how to start with our chemical plant design. This is what we call base case. Okay, since you already identify the product, select the most suitable technology and process, then now you need to prepare a complete process flow sheet. Process flow sheet, that means the block diagram. Okay, do you know what is a block diagram? The diagram that you draw in your mass and energy balance, that one we call block diagram. But since now we already know how to draw the block diagram by using the simulation software, for example, Xmen HYSYS, Pro 2, okay, then we can directly actually to try to produce the block diagram by using this simulation software. If let's say you produce this block diagram by using this simulation software, then the block diagram that produced is also known as process flow sheet. Okay, so means that until this step, you already identify the equipment that you want to use. What are the processes that you are going to carry out in in all the equipment? And also you know how are you going to link this equipment or unit operation together in order to come up with a complete process flow sheet. Once you already come up with a process flow sheet, then you can directly to try to solve the mass and energy balance by using the simulation software. Similar to what I teach in material and material and energy balance, and also the chemical engineering thermodynamic simulation. And also we can also use the software to assist us to optimize the process as well. We call process optimization. Okay. And also you need to make sure the design, the process flow sheet that you come up here is actually controllable. That means that can actually easily to be controlled by using the common control system. Okay. Once you come up with a complete PNID, okay, PNID, you already complete a PNID, then you can proceed to determine the size of the reactor, storage tank, or heat exchanger that you are going to use in your chemical plant here. Then only you proceed to calculate the cost that required in order to construct a chemical plant here. Okay, but of course, when you calculate the cost, okay, we will also try to calculate again the profit, okay, that we can make based on the capital cost here. Okay, if let's say later in our calculation here, if let's say we have any problem with our profit, okay, then what we need to do is we need to go back to step number 6 here to see, is there any possible amendment we can make in our process flow sheet here in order to make sure our chemical plant can generate money for us. So if let's say based on the cost that you calculate and also the profit you calculate, your chemical plant is perfect, okay, the cost is low, and somehow you can generate a lot of money, then you can proceed to step number 8. If not, you may need to go back to step number 6 here to see any amendment or revision you have to make. Okay, you can make in order to make sure your chemical plant design is actually can assist you to generate money. Okay, so that's why step number 7 here, we assess the economic viability of process is very, very important. Okay, normally here you need to try to get the approval or green light from your superior before you can proceed. Once they already give you the green light approval, okay, then now, okay, you can try to review, okay, the process, okay, the chemical plant that you design here based on the environment, safety, and also the health effect aspect to make sure, okay, they're actually eco-friendly enough and some more can be safely operated. Okay, once you are done with step number 8, then we can proceed to step number 9, okay, to come up with a very complete process design report. Okay, so after you prepare the process design report, then we can proceed to step number 10. Okay, we can complete the final engineering design. Okay, what does it mean? Just now you already come up with your process flow sheet. You already determine how big is your equipment, what is the size of your reactor. Okay, now you need to try to proceed, okay, to come up with a complete layout. How you are going to arrange them, okay, where you are going to place your storage tank, where you are going to construct your distribution column in the location that you select. Where are you going to construct the control room to try to control and monitor the process? This is what we call process layout. This can only be done once you already finalize your design. Okay, and also don't forget, you need to try to link and connect all the unit operation and equipment and storage tank together by using the pipeline. So you also need to know how the piping is going to connect this all equipment together in order to form a complete system. Okay, this one we call piping engineering. And what are the material we are going to use to construct the pipeline? How big is the diameter? How long is the pipe? Okay, you need to consider this, what we call piping engineering. Okay, then if let's say for the equipment, the reactor you are going to use in your chemical plant, okay, you are going to ask the contractor to try to construct for you. Okay, then later you'll need to try to search the potential contractor, and normally the contractor, they will come up with a quotation, or we call tender, okay, based on the equipment that you are going to design. They give you a tender, a quotation, then only based on the tender and quotation they provide, okay, then only we try to decide which contractor we are going to appoint them to assist us to try to construct, okay, the equipment, okay, that we are going to use in our chemical plant. Okay, this one is under the step here. Okay, okay, but some of the equipment or unit operation, let's say you are going to construct the unit operation by yourself in your own company wall. This is what we call the work is done in-house. So in this case, we need to try to procure, to buy the equipment and material that require. Once we have the equipment and also the material, then only we can proceed to try to construct the unit operation, okay, in-house. Okay, sometime, okay, normally engineer, especially we are chemical engineer, okay, we need to try to cooperate with the engineer, with the other engineer that come with different discipline or background. And sometimes they will try to call a meeting and ask you to sit down together with them in order to further discuss your design and also your drawing. And in that case, okay, you might need to provide some of the assistance and information to them in order to support them to complete the construction. Once the chemical plant is successfully, okay, constructed, okay, we need to try to what we call is try run the chemical plant, okay, to make sure the chemical plant can actually be operated, okay, as our expectation. And also we need to make sure the quality of the product that we are going to produce is actually similar to what we expect. Okay, so that's why before we officially, okay, use the chemical plant that we design to produce a product, we need to try to produce a product, okay, in small scale, okay, by using the chemical plant first. This is what we call shakedown run. Meaning that, okay, before we officially, okay, to use that chemical plant for the mass production to produce our product, okay, we need to try to check and make sure it can actually operate, okay, similar to our expectation, can be controlled, and also the quality of the product is that the product is actually similar to our expectation. This is what we call shakedown run. If let's say the process cannot be operated, then we need to try to figure out actually what happened with our design. Then we may need to try to revise a bit the design or maybe the system before we can officially use the chemical plant to produce our product and supply to the market. And basically, these are the steps or framework or the element that we need to consider under the guideline and framework that proposed by Peter. Okay, and this is also the common guideline or framework that normally we use and refer to for our chemical plant design. So meaning that, okay, normally, okay, based on my past experience, your senior, when they try to prepare the chemical engineering design project in their final year, normally they will follow the step that I explained here. So meaning that normally they will refer to the framework or the guideline that proposed by Peter. Why? Because this is actually considered as one of the most common step or framework that we normally follow in our chemical plant design. Okay, so far any question before I proceed to the second framework? Shini, so far do you have any question before I proceed to the second framework? No. Okay, thank you. Okay, the second framework that proposed, okay, is this one. The framework here is actually proposed by Cider. Okay, this is also the framework that actually we can also refer in order to initiate the chemical plant design. First, okay, we start with project charter. What is project charter? Project charter, that means you need to identify the need. You need to know what is the product that you want to produce. Okay, what you actually want to do in your chemical plant design. This is what we call project charter. Then second, you need to identify, is it involve any material technology invention? Meaning that, do you need any very special material in your design here? Okay, yes, then you need to proceed to try to get the relevant material technology. Okay, you need to try to do some invention. Okay, this is what we call material technology invention. If no, then we can directly to proceed to the third step we call process or manufacturing technology. So meaning that in your design, is it involve any very special process invention or technology invention? Yes, you need to figure out what is it, okay? And then you need to try to consider actually later how are you going to try to get this technology development or invention. If no, then we can directly to proceed to next step. Okay, so after that, we proceed to the concept stage. Under the concept stage, you need to try to develop the concept for your chemical plant. The first one is, okay, you need to know who are the potential customer of your chemical plant. Okay, what is the company? What is the potential customer you are going to supply the product that you are going to produce based on the chemical plant that you are going to design? After that, you need to create a data bank or database to try to collect the relevant information that you need in your chemical plant design later. Okay, once it's done, then you can proceed to the preliminary process synthesis. You are going to try to identify what is the process and technology that actually you are going to use and you can apply in order to produce a product that you want to produce. Okay, you need to identify what is the potential chemical reaction, separation process, and even the equipment that you need in order to produce the product you want. Okay, and under the CIDR, the framework that proposed by CIDR, normally the concept, they will try to prove it by using the bench skill lab work. Bench skill lab work means lab skill experimental work. Means that once you already select the technology, the equipment, the process, they will try to run it, do it in the lab to make sure it's actually practicable before we move on to further design the chemical plant, to design the equipment. This is what we call bench skill laboratory work. Okay, gap review here is actually one of the steps that normally involve in the project management. Gap review, that means yes or no. Meaning that based on the concept stage here, is it practical? If yes, then only we proceed. If no, that means the concept here is actually not practical, cannot be used for chemical design. So that's why they will just ignore the process, then redo again. Okay, try to come up with a new technology and new process again. Okay, this is what we call gap review. So in this case, if let's say the concept is proven practical enough, then only we proceed to the next, we call feasibility stage. In the feasibility stage, okay, what you are going to focus first, since okay, you already selected the suitable technology and process, and this selected technology and process, they will become the basis, or we call base case, okay, for your chemical plant design. After that, okay, based on the selected technology and process, okay, you try to use the simulation software to try to come up with a process flow sheet, okay, and try to connect all the equipment together, and then you can try to solve all the unknowns. For example, the heat energy that involved, the mass flow rate, the volumetric flow rate, by using the simulation software. Okay, and under the framework that proposed by CIDR, they also suggest the engineer, if possible, try to construct and come up with a pilot plant in order to try run the process that you design here. What is pilot plant? Pilot plant is actually can be considered as a chemical plant also. And this chemical plant, its size is much smaller compared to the real chemical plant that you are going to construct based on your design. Okay, and the function why they try to build the pilot plant, because they want to try run the selected technology and process that you consider and use in your technology, in your plant, in your design here, to try whether, okay, it can produce a product that you want to produce or not. And also based on the pilot plant here, sometimes it can also provide some of the extra information or useful supporting data that actually we can try to consider them as the reference for our subsequent design, okay, in our chemical plant here. Okay, this is what we call pilot plant. But compared to the real chemical plant that we are going to construct, the pilot plant, normally their size is much smaller than the real one. And normally the pilot plant, they are constructed indoor. Okay, they still considered as a chemical plant, just only their size is smaller than the real chemical plant. Okay. Okay, once the feasibility stage here is proven, okay, approved, can proceed, then only we go to development stage. If not, then maybe we need to do some revision. Okay. Okay, now we proceed to the development stage. Okay, just now we already proved the concept. Okay, some more we already construct the pilot plant. Okay, we can produce a product by using the selected technology and process. Okay, complete. Okay, then now it's time to proceed to the development stage. Under the development stage, we can start to try to do the mechanical design for the equipment or unit operation that involve in the process flow sheet. Okay, and also, okay, we can do some analysis, okay, based on the safety aspect for the process flow sheet. And also we can start to try to develop the startup strategy, how we are going to start to construct, okay, this design here. Okay, we try to get the contractor, or maybe we want to do it in-house. So all of them are considered under the development stage. Okay, if let's say the development stage here is done and approved, then only we can proceed to the manufacturing stage. Manufacturing stage, that means we will start to try to construct the chemical plant. Okay, once the chemical plant is done, then also similar, we need to try run the chemical plant to make sure it can actually safely operated, okay, as per our planning and expectation, and also the quality of the product produced is actually meet our requirement before we officially, okay, use the chemical plant to produce our product. Okay, once here is approved, then only we can proceed to the manufacturing stage. Okay, to start to manufacture, produce our product. Okay, so once we start to can officially use the chemical plant to produce our product, then now it's time we try to determine what is the price of the product that we are going to commercialize to the market. Okay, what is the marketing strategy? Okay, so which YouTuber we are going to pay them, then ask them to try to introduce our product. What is the marketing strategy? Okay, and also how we are going to try to introduce our product to our potential customer, and also how we are going to compete with our competitor. Okay, so all of them are considered under the product introduction stage. Okay, okay, then we can start to try to, okay, supply our product to our customer and also supply to the market. And this is the framework or guideline that proposed by Cider. And some more the steps start from the concept stage here, you see, until the step here, this one, okay, the borderline here, Mr. Cider, they already applied trademark, okay, IP to protect their framework here. But we still can try to refer the framework here for our chemical plant design. Okay, so, but if let's say you compare the framework that proposed by Cider and also the framework that proposed by Peter, okay, the element or stages that involved in the chemical plant design, you see they are actually totally different. Okay, but as I told you just now, plant design is actually an open-ended task. Okay, that means no correct answer, no wrong answer, no SOP. Okay, depends on which framework and also which guideline we prefer, and we think they are actually more suitable to be referred to in order to initiate to proceed our chemical plant design. Okay, but I would say that the framework that proposed by Peter is the most common framework that normally we refer and use in our chemical plant design. So that's why I strongly encourage you to try to learn how to actually refer the framework or guideline that proposed by Mr. Peter, okay, as a reference for your chemical plant design. Okay. Yeah, and sometimes depends on the nature of the chemical plant and also the type of the chemical plant that you are going to design. Sometimes, okay, even you follow the framework or step that given by Mr. Peter here for your design, but due to the nature of your design or the nature of the chemical plant that you are going to design, okay, sometimes you may need to modify a bit the element or stage that involve in the framework that proposed by Mr. Peter. But this one is actually subjected to any possibility. Okay, because sometimes maybe you have some other consideration, or maybe the nature of the chemical plant, okay, is not allowing you to follow some of the element or stage that proposed by Mr. Peter. Then in that case, you are actually have the freedom to try to modify a bit accordingly, okay, according to your requirement or the situation. Okay. Okay, basically these are the two frameworks that normally we refer to in order to come out with a chemical plant design. Okay. So you see in our today lecture one, I just try to share with you what is chemical plant design and what are the framework and also the guideline that we normally can refer to in order to design the chemical plant. Okay, and also what are the components that actually we need to deal with. Okay, we need to implement, we need to carry out. Okay, under the step or the process that involved in the framework that proposed by Mr. Snyder and Mr. Peter. Okay, but of course later in other chapter we will try to go in detail for the step that actually I try to explain to you in the framework here. But until today's lecture, at least you have to know, oh, actually there are two different frameworks we can refer. Okay, we can refer for our chemical plant design. Okay, at least you have some idea what are the considerations we need to consider in our chemical plant design. Okay, and also what are the steps that actually involve, okay, in the framework that I try to explain to you just now. Okay, no correct and no wrong answer. Remember, design is always an open-ended task. Okay, okay. So far, any question before we proceed? Okay, if no, then maybe I can proceed a bit. Okay. Okay, so just now I already shared with you and introduce some of the framework or guideline that we normally use in our chemical plant design to you. Okay, so now I will try to explain a bit to proceed to try to share with you a bit. Okay, what are the common consideration that actually we need to consider in our design? Okay, first, okay, the selection of the process. Okay, for example, now we want to produce the formaldehyde. So as I told you just now, if let's say we refer to the framework that proposed by Peter, okay, we need to identify the possible pathway or reaction or process that actually we can apply to produce our product formaldehyde here. We need to do some literature review or we need to Google a bit. And based on our literature review, there are two different pathways we can apply to produce our formaldehyde. The first one is the oxidation of natural gas based on dehydrogenation. The second one, okay, is we try to use the carbon monoxide and hydrogen to produce our formaldehyde here. There are two different reactions, two different pathways. So in order to make sure our design is optimum, then we need to consider which reaction or process, actually we need to consider them and select as our basis, as our base case study to assist us to try to initiate our chemical plant design. Okay? Okay, so as I told you, the top priority is always given to the profit. We will try to evaluate the selected the process here based on their gross profit. How to calculate the gross profit, how to calculate their economic performance, we will cover in our tutorial too. Okay? And also, if let's say all of these processes that can generate money, okay, we can gain profit, then only we proceed to consider other factors. For example, what is the operating temperature that involved? Which one is lower? Which one is higher? Which technology is actually complicated? The equipment that we are going to use, can it be purchased or found in the market? If not, can we design ourselves? Okay, and so on. So later, we also need to consider all these considerations to make sure the process that actually we select is actually optimum enough, okay, in order to how to say, to improve the quality, okay, of the design that we are going to produce. Okay, so beside that, okay, as I told you just now, okay, you also need to reduce the cost that you need, okay, to construct the chemical plant. So there are a lot of decisions that can actually decide, okay, and influence the cost or the money that you are going to spend to construct your chemical plant. Okay, for example, the selection of the suitable pipe dimension. You will actually influence your cost and determine the cost of your chemical plant. Okay, let's say, for example, you see, here is the pipe diameter. Okay, common sense. Okay, the bigger the size or bigger the diameter of the pipe you are going to use, let me check correct or not. Right. Okay, when you increase the size or diameter of the pipeline, then definitely, okay, common sense, the fixed charge of the pipe here, the fixed charge of the pipe that you are going to use will also increase. So what is fixed charge? Okay, fixed charge is actually the, for example, the cost of operation, the installation cost that you are going to install the pipeline. Okay, the bigger the diameter of the pipeline, the more the fixed charge you are going to spend for the pipe that you select. Okay, but at the same time, when you increase the size or diameter of the pipeline, you can reduce the cost or the money that you are going to spend for the pumping power also. Okay, what is pumping power? Pumping power, that means the function of the pipeline in the industry is you want to make sure the fluid, the process stream, can flow inside the pipeline. In order to ensure the process stream can flow inside the pipeline, you need to install a pump in order to supply the power to the process stream to make sure the process stream can flow inside the pipeline. Okay? But the power that you need to supply to the process stream to make sure it can flow inside a pipeline is actually determined and influenced by the selection of your pipe diameter. The bigger the pipe diameter you are going to use, the lower is the frictional force between the process stream and the inner surface of the pipe. So in that case, since the frictional force is low, meaning that the lower the power you need to supply to the process stream to ensure it can flow inside the pipeline or keep flowing inside the pipeline. So when the power that you need to supply is low, meaning that the money, the cost that you are going to use to purchase, to install, to operate the pump will also be reduced. So that's why you see when you increase the pipe diameter, the cost for the pumping power will also reduce, even though the fixed charge increase directly proportional to the pipe diameter. So that's why in this case, we need to try to determine an optimum design to see which diameter actually will try to assist you to minimize the fixed charge and maximize the saving or reduction in the cost of pumping power. And we need to consider in order to determine the optimum pipe diameter. And this is actually how the selection or decision we make in the design. For example, the pipe diameter can actually influence and determine the cost of our chemical plant. Okay. Similar, the smaller the pipe diameter, normally the bigger is the frictional force between the process fluid and also the inner surface of the pipeline. Since the frictional force is bigger, okay, what we need to do is we need to supply more power. When you want to supply more power, then what we call the pump with higher horsepower, HP, you need to purchase, you need to operate. Then of course, the higher the cost you need to pay. Okay, so in this case, that's why the selection of the smaller pipe diameter, it will significantly increase the cost for pumping power. Okay, this is actually how the economic consideration is important in order to make sure we can reduce the cost and maximize the profits that we are going to generate. Okay. Okay, so I think I need to stop here, okay, because it's 4 o'clock already. And Kuma, okay, some more Kuma later, he need to go to other classes. Okay, so in our today lecture, at least you know there are 2 different framework or guidelines that normally we can refer for our process plant design. First one is the framework proposed by Mr. Peter, and the second one is actually proposed by Mr. Sider. And also just now I already tried to share with you and explain with you, okay, how this consideration can actually determine, okay, and design our chemical plant design. Okay, for the rest, okay, I will try to explain by using the tomorrow tutorial. Okay, tomorrow tutorial, it will be conducted physically in our campus. Okay, we will proceed to finish our lecture before we proceed to our tutorial 1. Okay, make sure you do some revision. As I told you just now, our today theory is very important because later you are going to refer to the theory that I explained today and the concept that I share with you today to initiate your assignment and also your final year chemical engineering design project in your final year. Okay, so any question? Attendance. Okay, Kuma, no need to panic. Okay, just now you enter my Zoom. Actually, I already record down all the attendance. Okay, later I will try to take your attendance according to the system, according to the report that generated by the system. Okay, no need to worry about it. Okay, so that's all from me for chapter 1. We will continue to finish our chapter 1 tomorrow and proceed to our tutorial 1. Okay, see you tomorrow and have a nice evening. Bye-bye.